Hi, welcome to the MERROW 60 restoration. I hope you enjoy the video. You can see how the two linear slides operate on that cam. This is the slide plate, and it slides up and down like that and oscillates like this at the same time. So these two can change the angle of this, right? So this plate it goes back on there. Right, pretty straightforward. Right there in the front we've got a pretty standard operation. Here's the one take up. And then there is another one. There's another one over there. See, so it's dual take up. So it's pulling two threads, and there's this eccentric here that creates that linear motion. Right. So it's come free now. What had corrosion on here, and this slide had got corroded on the actual, you can see the mark there. So this was stuck, basically corroded in that position. So it had jammed those cam spools, and you can see how it works. Just exactly the same as a motorcycle gearbox. Very simple cam arrangement. A lot of cams work like this. The old auto lathes worked like this before the days of CNCs. So there we are, and that's pretty much a standard sewing machine action, that front action. There, my sewing machines work like that. There was a screw I was trying to get out, but I still haven't managed to get it out. I managed to get this sliding bit off there. So there we are. Okay. So here we go. We're gonna remove these. The screw goes into an indent on this shaft. Once that is removed, that shaft comes out. You have a pin here and a pin there. These two pins they mesh every revolution. If you get this timing out, then that will hit up, it won't turn. So there's only one way you can put it back. Apart from the fact that these two shafts are both indented. That one on that point, and this one on that point. So really, it's just a matter of pulling this to get that shaft out. It's pretty straightforward. You have to push it out from the side. This shaft, a little more awkward because it comes out. If I just move this a little bit. Okay, so that shaft is there, you can see it there. This is the plate that it's the pressure plate. Takes up the pressure, pushes from the other side, and it puts pressure on the slide. Puts pressure on this slide here, and it nips the slide so that you don't have any lateral movement on this mechanism going up and down. It's just to assist the accuracy of the timing positions. So that is in on a peg that goes into the body itself. The peg is held in by a screw on the other side. At the moment, and that's the reason why I'm taking this apart. At the moment, the peg is turning in the casting. instead of turning in its bush. So when I tighten the screw on the other side, the seizes, and as you can see, it isn't moving. Now I'm going to continue taking this apart, clean it all up nicely, because now I've become aware of the fact that this company started in 1838, same year that Martin Guitars started. And like Martin Guitars, they're still in existence today. And they still make overlocking machines, believe it or not. These, the spares for this machine are still available. Hopefully we can get the little bits and bobs that we need. To complete the ornament, there isn't much missing on it. And the hook is, the one hook, as I mentioned earlier, is in fact broken. I have found the manual now online, but no detailed drawing of the machine itself. But I have a threading diagram, and so that's kind of inspired me now to take it a little further. Let's clean it up properly and see if we can get it. I can order a new one of these tensioners for here, and we'll see what we can come up with. Okay, I've taken that screw out, and I'm just to show you after 90 years. By the way, I put the serial number of this into the company, and this machine was built between 1930 and 1934. So it's 90 going on 90 years old. And I'm pretty certain this shaft has never been out. But now let's have a go at pulling that out. Look at that. You can feel there the barrel just falls. And I can feel that this housing has very, very little wear in it. I've got it extended out here about 150 mils, and I just support it there. You can see there is virtually no flex, so I'll be surprised if there's even a thou clearance on this shaft. Right, so that's that shaft out. Getting the other shaft out is going to be more fun, because it's kept there, but I'll turn this upside down and see if we can just tap it gently on here with a bit of wood. Let's see if we can just get it to move. A bit of wood. Oops. And I think you can see. Okay, so now we have this off. As you can see, this, unfortunately, it was stuck in there. This actually supposed to rotate. It gets screwed into there, and of course it gets screwed, and this is screwed into here, and that actually rotates on this taper. Sorry, I'm getting a bit tongue-tied. And this screw here, that I was telling you about earlier, clamps the thread on here. So you screw this in, set the limit on it, just enough for it to move, but without it being solid up against the body. And that's how that works. And this, of course, goes onto this shaft, and there's the cam that operates that. Now I've got to get this shaft out. Listen, the cutter mechanism pivot point has been removed. As you can see there back here, we removed that. Right. Okay, so now the reason why you don't hit things with a big hammer and just with a piece of wood, turns out that this shaft comes out forwards, not backwards. So, but it's pretty easy to push. And there's a hole in the back here that has a screw in it. Just get it out of the way of. And I'm pretty sure if I push from here, I'll be able to push the shaft out. Right. Push the shaft out. And there's the locating pin. Look at this quality of this shaft. It is 90 years old. Piece of tool steel. That's where it's been running in the cast iron, but I cannot feel. And I reckon if I put a mic on here, you might not. There's not even half a thou wear on here. It just needs a bit of 5,000 water paper. It's extraordinary, absolutely extraordinary. And I want to turn this around now. Right, now this obviously comes out by taking the top one out first. Right, so take the top one out first, then you can get the bottom one out. So I'm going to stop the camera now because I can't see unless I hold it here. I just don't want anything to fall out that shouldn't. So there is the carrier of the cutting. And can you see, look at the size of everything on this in terms of how big it is. And this is where the security of this cutting system comes from. It is just so, it's so well engineered. There's a little cap on the top. So this is the one barrel. And then the other barrel obviously comes out once you get that one out. Anyway, I'm going to have to fiddle that out and put something underneath and get it out. So it comes out with this cam, the other take-up cam, which is here on the front of it. Let me see if I can get my hand in there. No, it's not light. Can't do it with one hand. Right. But you get the gist of it. So this one is out. As you can see, it came out without its the other part, which is inside there, and it pivots on a pin at the back inside the housing. This is the take-up. So that's how they've gone about that. This one doesn't have an external pin like the top one does. And you see all the muck in here, loads of it. So I'm very happy to have what is also very significant in the longevity of this machine is the length of the journals. These bearing journals, cast iron journals are, what, 2 inches, 2.5 inches long. Top one is about 2.5 inches, and the bottom one is almost 3 inches long. Which just, in terms of wear, when you compare it to modern pieces of equipment where you might have a journal of 20 millimeters long. What's the average length of a coated bush? 20 on a shaft this size. I reckon you'd battle to find one longer than 20 millimeters. I'm talking about a glacier, whatever way you pronounce it, top bush, which I used a lot in machine making. They're good because they survive well with marginal lubrication. But this machine is just made to last forever, as its testimony to it when you see parts coming out of it. Okay, till later. So that edge there, 1.5, that is 1.5. This is 1 mil there, and this is 1.7. So it doesn't matter if you turn it over in that plane. The 1 mil side must face the front. You can't get it wrong. So with this one, it's pretty much the same arrangement. There's the cam in there. This is the front. Right, so I'll lift off the cutter cam, trimmer cam, and if I lift that up, you can see that the thin part is at the front. There's the 1.5 there, 1.5 there, and I'm pretty certain if I move it over to this, they're identical. They are too. But I'll leave that one with its partner. They have been in love for 90 years, so we won't interfere with that relationship. So here we go. So 90 years old, been out in the elements for at least 30 years. I'm not joking, folks. This thing has been outside in the elements for around 30 years. It has removed all the paint. It's rusted all of this. The take-up that was here was rusted beyond repair. The reason why this survived, cast iron, very weather resistant, and of course things that are hardened to the degree that this has been hardened. Just incredible how long-lived they can be in comparison to today's machinery. Today's machinery, you leave it out for a week, it is completely destroyed. And you want to tell me that the world has not gone mush? Well, I've lived a bit, and it certainly has. There are very few people alive today that could produce this the way it was produced 90 years ago, with no automatic machinery. Now, all of these centers that create the mesh between these two, all were done on mechanically and manually moved machines. It is astonishing, the workmanship in this. It's as good as any rotary or Swiss-made watch. Pity we've lost all these skills. Anyway, I will now go about cleaning this all up. and reassembling it.